HashMaps explained, step-by-step introduction. A HashMap is a data structure that stores data as key value pairs. Software engineers use HashMaps for fast lookup, frequency counting, caching, grouping data, mapping IDs to objects, checking if something exists, solving interview problems, backend response transformation, duplicate tracking with counts, user/session lookup. A common learning topic is, how can beginners understand HashMaps step by step using Java? This guide explains HashMap basics, key value pairs, put get remove, containsKey, getOrDefault, frequency counting, toSum, grouping, counting characters, HashMap versus HashSet, common interview patterns, Java examples, debugging tips, common mistakes, interview questions. Simple definition. A HashMap stores. Key means value. Example. Student name means score. John means 90. Mary means 85. Alex means 95. Java. Map, string, integer, scores equals new HashMap dot. Scores dot put John, 90. Scores put Mary, 85. Scores put Alex, 95. Get value. Int John score equals scores.get John. Output 90. Why HashMap matters. HashMap is very important because it gives fast lookup. Without HashMap, search through list one by one. Time O(n). With HashMap, direct lookup by key. Average time O(1). Example. Find user by ID. Without HashMap, loop through all users. With HashMap, user, map get user ID, HashMap big picture, HashMap, key 1 means value John, key 2 means value Mary, key 3 means value Alex. Java. Map integer string, users equals new HashMap, users put 1, John, users put 2, Mary, users put 3, Alex. Access. Users.get2. Output. Mary HashMap syntax in Java. Import dot. Import java.util HashMap. Import java.util.map. Create. Map integer string map equals new HashMap. Add value. Map.put 1 apple. Get value. String value equals map.get1. Check key. Map contains key 1. Remove. Map.remove 1. Size. Map.size. Step 1. Put data into HashMap map. Integer string products equals new HashMap. Products put 101 keyboard. Products put 102 mouse. Products put 103 monitor. HashMap. 101 means keyboard. 102 means mouse. 103 means monitor. Step 2. Get data from HashMap. String product equals products.get101. System out println product. Output. Keyboard. If key does not exist. Products.get 999. Output. No. Step 3. Check key exists if products.containsKey 101. System.outprintln product exists. Use containsKey when. Check. You need to check existence. Check. Value may be null. Check. Avoiding wrong assumptions. Check. Solving lookup problems. Step 4. Remove key products. Remove 102. Before. 101 means keyboard. 102 means mouse. 103 means monitor. After. 101 means keyboard. 103 means monitor. Step 5. Update value. If key already exists, put updates value. Products put 101 mechanical keyboard. 101 means keyboard. After. 101 means mechanical keyboard. Important. HashMap keys are unique. One key can have only one value. Step 6. Iterate HashMap. Iterate keys for integer key, products key set, system.nt.println, key. Iterate values for string value, products.values, system.println value. Iterate entries for map entry integer string entry, products.entry set, system.println entry get key plus means entry get value. Entry.get value. Best for key value access. Entry set. Step 7. getOrDefault. getOrDefault means get value if key exists, otherwise return default value. Example: map string integer count equals new HashMap. Int value equals count.getOrDefault apple 0. If apple does not exist, value equals 0. Very useful for frequency counting. Step 8. Frequency count. Problem: count how many times each number appears. Input: 1, 1, 1, 2, 2, 3. Output: 1 means 3, 2 means 2, 3 means 1. Java. Public map integer integer count frequency integer nums. Map integer frequency map equals new HashMap. For int num dot nums, frequency map dot put num, frequency map dot getOrDefault num 0 plus 1. Return frequency map. Frequency count dry run. Input: nums equals 1, 1, 1, 2, 2, 3. Start. Frequency map equals q. Read 1. getOrDefault 1, 0 equals 0. Put 1 means 1. Map 1 equals 1. Read 1 again. getOrDefault 1, 0 equals 1. Put 1 means 2. Map 1 equals 2. Read 1 again. 1 equals 3. Read 2. 1 equals 3. 2 equals 1. Read 2 again. 1 is 3. 2 is 2. Read 3. 1 equals 3. 2 equals 2. 3 equals 1. Step 9. Character frequency. Problem: count characters in a string. Input: banana. Output: B means 1, A means 3, N means 2. Java. Public map character integer count characters string S. Map character integer frequency map equals new HashMap. For char ch s to char array, frequency map dot put ch, frequency map dot getOrDefault ch 0 plus 1. Return frequency map. Add. Step 10. To sum using HashMap. Problem: find indexes of two numbers that add up to target. Input: nums equals 2, 7, 11, 15. Target equals 9. Output: 0, 1. Why? 2 plus 7 equals 9. Java. Public int toSum int target map integer scene equals new HashMap. For int I equals 0, I length nums I plus plus. Int current equals nums I. Int needed equals target minus current. If scene.containsKey needed, return new int address scene get needed. Scene.put current I. Return new int. HashMap stores. Number means index. Dry run. I equals 0. Current equals 2. Needed equals 7. Scene equals 0. I equals 1. Current equals 7. Needed equals 2. Scene contains 2. Return 0, 1. Step 11. Grouping with HashMap. Problem: group employees by department. Example: IT means John Alex. HR means Mary. Finance means Sarah. Java. Public map string list string group by department list employees. Map string list string department map equal new HashMap. For employee employees. String department equals employee.getDepartment. Department map.compute if absent department key new array list function .add employee.getName. Return department map. Important method. Compute if absent. Meaning, if key does not exist, create new value. Then use it. Step 12. Group anagrams. Problem. Group words that are anagrams. Input. Eat, tea, tan, ate, nat, bat. Output concept. Eat, tea, ate, tan, nat, bat. Java. Public list string. Group anagrams. String strs. Map string. List string. Map equals new HashMap dash. For string word. strs. Chars equals word to char array. Arrays.sort. String key equals new string chars. Map compute if absent key. K new array list play close. Add word. Return new array list. Map dot values. Key idea. Anagrams have same sorted string. Example, eat means 8. T means 8. 8 means 8. HashMap dot. AET means eat t 8. Ant means tan nat. ABT means bat. Step 13. Top K frequent elements. Problem. Return K most frequent numbers. Input. Nums equals 1, 1, 1, 2, 2, 3. K equals 2. Output. 1, 2. First step. Use HashMap to count frequency. Map integer, frequency map equals new HashMap. For int num dot nums, frequency map dot put num, frequency map dot getOrDefault num, 0 plus 1. 1 means 3, 2 means 2, 3 means 1. Then use sorting, heap, bucket sort. HashMap is the foundation of this problem. Step 14. Cache-like lookup. HashMap can act like a simple in-memory cache. Example. Map long product response product cache equals new HashMap. Store. Product cache.put 1001L product response. Get. Product response cached equals product cache get 1001L. Simple flow. Request product 1001. Check HashMap cache. If found, return. If not found, read database. Store in HashMap. Important. HashMap cache is only local memory. For distributed apps, use Redis or another distributed cache. Step 15. HashMap versus HashSet. Feature HashMap HashSet. Stores key value pairs, unique values. Example number means count unique numbers. Use case frequency count index, duplicate check. Java type map KV, set E. Use HashMap when you need value associated with key. Example, number means index, character means count, department means employees. Use HashSet when you only need to know if value exists. Example, contains duplicate visited nodes, unique IDs, step 16, HashMap complexity. Average case. Operation complexity, put 01, get 01, contains key 01, remove 01. Worst case, ON. But for normal interview explanation, HashMap operations are average 01. Space complexity, ON. If storing up to N keys. Step 17, HashMap with custom object. Example, class product, private long ID, private string name, private big decimal price, public long get ID, return ID, public string get name, return name. Map. Map long product map equals new HashMap. Store. Product map put product.getID product. Lookup. Product equals productmap.get 1001L. Used for check lookup by ID, avoiding nested loops, joining data from two lists, response transformation. Step 18. Avoid nested loop with HashMap. Problem. Attach product details to order items. Bad nested loop. For order item item order items. For product product products. If item get product ID equals product get ID, item set product name, product get name. Complexity. Published. O, N times M. Better with HashMap. Map long product. Product map equals new HashMap. For product products, product map put, product get ID product. For order item order items, product equals product map, get item get product ID. If product equals null, item.set product name, product.get name. Complexity. O of N plus M. This is a very important real-world backend pattern. Step 19. Convert list to map. Example. Public map long product to product map. List of products. Map long product map equals new HashMap. For product products, product map put product get ID product. Return product map. D. Using streams. Map long product map equals products.stream.collect collectors.toMap product get id product. Be careful. Collectors to map throws error if duplicate keys exist. Safe version. Map long product map equals products.stream collect collectors.toMap product get ID product old value new value old value. Step 20. HashMap debugging. When debugging HashMap problems, print current key, current value, needed complement map before update, map after update. Example. Systemout.println current equals plus current. Systemout.println needed equals plus needed. Systemout.println map equals plus seen. For frequency, system.out.println num equals num. System.out.println frequency map equals frequency map. Ask. 1. What is the key? 2. What is the value? 3. Am I checking before putting? 4. Am I updating count correctly? 5. Do I need HashMap or HashSet? 6. What should happen if key does not exist? 7. Can duplicate keys appear? 8. Can value be null? Common beginner mistakes. 1. Confusing key and value. Example. HashMap stores number means frequency. For frequency map, key equals number, value equals count. Wrong thinking. Key equals count, value equals number. This causes confusion in top K problems. 2. Forgetting getOrDefault. Bad. Frequency map put num, frequency map get num plus 1. Problem. If num does not exist, frequency map.getNum returns null. Then null plus 1 crashes. Correct. Frequency map put num, frequency map.getOrDefault num 0 plus 1. 3. Using HashMap when HashSet is enough. For contains duplicate, this is enough. Set integer seen equals new HashSet. You do not need map integer map equals new HashMap int unless you need counts. 4. Checking after putting in to sum. Bad. Scene.put nums I. If scene contains key needed, return new int, scene get needed I. Problem. May use same index twice. Correct. If scene.contains key needed, return new int array, scene get needed I. Scene put nums I. 5. Comparing integer objects incorrectly. Usually use objects equals A, B, or unbox carefully. 4. Map keys. Map contains key is usually better than manually comparing. 6. Modifying map while iterating. Bad. For integer key, map.keyset, map.remove key. This can cause problems. Better. Iterator, integer, iterator equals map.keyset.iterator. While iterator has next, integer key equals iterator.next. If key equals negative, iterator.remove. Or collect keys first. List integer keys to remove equals new array list. For integer key, map.keySet. If key is less than 0, keys to remove.add. For integer key, keys to remove, map.removeKey. 7. Assuming HashMap keeps order. HashMap does not guarantee insertion order. If you need insertion order, map string integer map equals new linked HashMap. If you need sorted order by key, map string integer map equals new tree map dot best practices. Caps use map_kv as variable type. Use HashMap as implementation. Use getOrDefault for counting. Use containsKey for existence check. Use entrySet when you need key and value. Use compute if absent for grouping. Use HashMap for frequency, index, lookup. Use HashSet for existence-only checks. Duplicate keys and streams. Remember, HashMap does not preserve order. Avoid storing unnecessary data. Dry run key value changes. Explain average O1 lookup in interviews. HashMap interview questions. 1. What is a HashMap? A HashMap is a key-value data structure that provides fast average lookup, insert, and delete operations. 2. What does HashMap store? It stores. Key means value. Example. User ID means user number, means frequency word, means list of anagrams 3. What is the time complexity of HashMap get, put? Average. O1. Worst case. ON4. What is the difference between HashMap and HashSet? HashMap stores key value pairs. HashSet stores unique values only. 5. Why use HashMap in toSum? Because we need fast lookup of the complement and its index. Number means index 6. Why use HashMap for frequency counting? Because we can map. Item means count. Example. 1 means 3, 2 means 2, 3 means 1, 7. What does getOrDefault do? It returns the value if key exists. Otherwise, it returns a default value. Example. Map.getOrDefault num0 8. Does HashMap allow duplicate keys? No. If you put same key again, it updates the value. 9. Does HashMap allow null keys? Java HashMap allows one null key, but in production code, avoid unnecessary null keys because they can cause confusion. 10. Does HashMap maintain insertion order? No. Use linked HashMap if insertion order matters. 11. What is TreeMap? TreeMap stores keys in sorted order. Basic operations are usually O log n. 12. When should you use HashMap? Use HashMap when you need fast lookup, frequency count, key value mapping, grouping, index lookup, caching like local lookup, HashMap roadmap beginner level. Learn. Create HashMap. Put, get, remove, containsKey, getOrDefault, iterate map, practice. Student score map, product ID map, frequency count, intermediate level. Learn. toSum, character frequency, word frequency, example, grouping, compute if absent, entrySet iteration. Practice. toSum, top K frequent elements, first unique character, group anagrams, advanced level. Learn. Cross. Linked HashMap, cross, TreeMap, custom object keys, cross, equals hashcode, stream to map, cross, duplicate key handling, caching patterns. Practice. LRU cache concept, group by field, join two lists by ID, subarray sum equals K, 30-day learning plan, week 1, HashMap basics. Learn. Key value pairs. Put get, containsKey, remove, size, iteration. Practice. Create student score map. Create product lookup map. Print all keys and values. Week 2. Counting problems. Learn. Get or default. Get frequency map. Character count. Get word count. Practice. Count numbers, count characters. First unique character. Contains duplicate with count. Week 3. Interview problems. Learn. Complement, lookup. Grouping. Top K frequency. Sorted keys versus unsorted keys. Practice. To sum, top K frequent elements, group anagrams, valid anagram, week 4. Real-world backend usage. Learn. CAX, ID lookup. CAX, list to map conversion. Avoiding nested loops. Grouping records. Local cache concept. Duplicate key handling. Practice. Map product ID to product. Attach product info to order items. Group users by role. Group orders by status. Real-world backend examples. Example 1. User lookup. Map long user, user map equals new HashMap. For users, user map.put user.getID, user. User equals usermap.get101L. Example 2. Group orders by status. Map string list order. Orders by status equals new HashMap duck. For order, orders. Orders by status. Compute if absent. Order.getStatus. Key new array list. Output. Created means order 1, order 2. Paid means order 3. Cancelled means order 4. Example 3. Count API errors. Map string integer error count equals new HashMap. For API error, string error code equals error.getCode. Error count put error code, error count.getOrDefault error code 0 + 1. Output. Validation error means 10. Auth error means 5. Timeout means 3. Example 4. Avoid nested loops. Map.long product. Product map equals products.stream. .collect, collectors.toMap. Product.product. Asterisk old value. Old value. For order item, order items. Product equals productmap.get, item.getProductID. If product equals null, item.setProductName, product.getName. This improves performance from O(n) times M. 2. O(n) plus M. Must know HashMap problems. 1. To sum. 2. Top K frequent elements. 3. Group anagrams. 4. Valid anagram. 5. First unique character. 6. Subarray sum equals K. 7. Longest substring without repeating characters. Isomorphic strings. 9. Word pattern. 10. Majority element. 11. Intersection of two arrays. 12. Find duplicate subtrees. 13. LRU cache. 14. Time-based key value store. 15. Contains duplicate II. Final summary. HashMap is one of the most important data structures for beginners and interviews. Important concepts. Key value pair. Put, get, remove, containsKey, getOrDefault. Frequency count. Grouping. Lookup. HashMap versus HashSet. Average O1 operations. Key idea. HashMap is used when you need fast lookup using a key. Use HashMap for. Number means index number, means frequency, character means count, ID means object, department means employees, status means orders. For interviews. If you see counting, lookup, grouping, or complement search, think HashMap.